Welcome back, friends. In today's session, we are going to continue with our topic of transportation plants. And as I told you in the previous session, that if you need these notes, you will visit the Kipaji app and then you will find these notes for the sake of memorizing yourself. Then it is free to share these sessions. And it is free to contact me to need any help regarding anything you have not understood in these sessions. And today we are going to start about the plant-water relations. Plant-water relations. When we are talking for the plant-water relations, we are discussing about the relationship between a plant cell and water. How the plant cell tend to respond when water either decrease or increase. So there are different responses by which a plant cell tend to respond. Maybe when water decrease or when water is increased. And in today's session, we discuss all of those things and even some of the calculations which are involved in this part. So let's start with the concept of water potential. We just introduced this when we discussed about osmosis. We introduced the concept of water potential, but today let's continue making this concept very well in our heads so that to make sure that if you meet with this concept in your exams, you are able to answer it well. Now we are saying that osmosis is the passage of water molecule from a region of the high concentration to a region of the low concentration through a partially permeable membrane or through a semi-permeable membrane. As I said when we discussed about osmosis, that the important thing in defining osmosis is that osmosis involves the movement of water molecules. Some people, they say that osmosis is the specific type of diffusion which involves the movement of water molecule. As we know, diffusion is the movement of molecules of a certain substance from the region of the high concentration to the region of the low concentration. That is the definition of our diffusion. But in water, we are moving water molecules from region of a high concentration or from region of their high concentration, that means from region of a high concentration of water molecule to a region of their low concentration through a partially permeable membrane. So some of the few major differences between diffusion and osmosis is that osmosis involves the movement of water molecules, while diffusion involves the movement of any molecule, even gas molecules. And another difference or another major difference between osmosis and diffusion is that osmosis occurs through a partially permeable membrane or a semi-permeable membrane. And diffusion can occur even in the open space. As we know, some of the examples of diffusion, examples of perfume, if someone sprays perfume even in the nearest room to you, the next room from you, and then you can smell the smell of perfume, because diffusion takes place through open space. Even in the classroom, if maybe a teacher sprays a perfume in his clothes, on entering the class you can sense the smell of perfume even if you are at the back of the class. This is because of the diffusion of the perfume particles from the point on the clothes of teachers to the point where you are. So diffusion takes place on open space, but osmosis takes place through a partially or a semi-permeable membrane. Now it is best regarded the form of diffusion in which only water molecule move. Only water molecule move, and they move in the partially permeable membrane. Now this diagram explains about osmosis, and we discussed it in the previous sections. As we said that here we have the partially permeable membrane, and then you can see we have the key here. This is the solute molecule and this is the water molecule. So if these small molecule, they are water molecule, and these larger one, they are solid molecule. Regarding this diagram, you will see these solid molecule, they are in high concentration in solution B as compared in solution A, or they are in high concentration inside B as compared with inside A. In other words, we can say solution B is more concentrated as compared with the solution A. So solution B is more concentrated because it contains large solute amount as compared with the solution A. So in terms of water molecule, because this solution is more concentrated, it will have a low concentration of water molecule, while solution A will have higher concentration of water molecule. And as we defined osmosis, that it is the movement of water molecule from the side or from the region of the high concentration to the side or to the region of the low concentration. That means in this solution here, osmosis will occur from A to B. This is because the region of a high concentration of water molecules, it is A, and the region of low concentration of water molecules, it is B. Now, again, let us introduce the concept of osmotic pressure. Osmotic pressure. As we know that in osmosis here, water molecule will move from solution A to solution B. These water molecule will be dragged or will be pulled by a certain force, and that force divided by area we get pressure. These water molecule will be pulled. This movement of water molecule by osmosis, it is because of a pulling of water molecule or attraction of water molecule to this solution B. So they will be attracted to solution B. Now there is possibility of applying a certain pressure here which can prevent this attraction or this movement of water molecule from solution A to B. As we know, the movement of water molecule from the high concentration to the region of the low concentration is called osmosis. That means the movement of water molecule from A to B, it is called osmosis. But there is the pressure which can prevent this movement of water from A to B. In other words, there is the pressure which can be applied in this side of concentrated solution, which can prevent the process of osmosis. Now, how do we call this pressure which can be applied on side of concentrated solution in order to prevent the process of osmosis? This pressure is what is known as the osmotic pressure. So osmotic pressure is the minimum amount of pressure which can be applied on the side of concentrated solution in order to prevent or to stop the process of osmosis. That is the easiest and the simplest definition of osmosis which can be understood by every student. Now we are saying that the solute molecules are too large to pass through the pores in the membrane, which is shown in the diagram previously, such that the membrane does not allow the passage of solute molecules. So the semi-permeable membrane, or it is called the partially permeable membrane, the reason behind it is called partially permeable. It is because it allows the movement of only few molecules. And the character of these molecules, they must be small as compared with the slits of the membrane. If the solute molecule, they are large, because the solute molecule, they are large as compared with the water molecule. So water molecules, since they are small in size, they can pass through the pores, while the solute molecule, they can't pass through the pores. So equilibrium can only be achieved by movement of water molecule. In order to achieve the equilibrium in the solution, only water molecule can move from one side to another. And as we said, solution A has a higher concentration of water, so there will be a net movement of water from A to B by osmosis until equilibrium is reached. At equilibrium, there will be no further net movement of water. So water will move from A to B until equilibrium is reached. So what we are saying that the tendency of water to move from one place to another is measured as water potential, represented by the symbol, this one, which is the Greek letter Psi, as we said before. So this Greek letter Psi represents what we call the water potential. Water potential. And it measures the tendency of water to move from one place to another. So As we discussed before that in order water to move from A to B, there must be a difference in concentration between A and B. So water potential, is how we shall discuss later, will be affected by the amount or concentration of a solute in the solution where water goes. If the concentration of solute is higher, that means the water potential also will be higher, is how we shall discuss later. But now let's go to discuss about the concept of water potential and its application in discussing about the plant-water relations. So we are saying that water potential, which is represented by the Greek letter psi, water potential is the measure of the tendency of water, or is the measure of the tendency of movement of water from one place to another. It's the measure of the tendency of movement of water from one place to another. So in water potential, we are measuring, or we are determining how water will move, the tendency of water to move from one place to another. Water potential is the fundamental term derived from thermodynamics. It is derived from thermodynamics. Thermodynamics is the study of pressure in relation to temperature. How pressure and temperature, they tend to relate to each other, is what we call it the thermodynamics. So water molecules possess kinetic energy, which means that in a liquid or gaseous form, they move about rapidly and randomly from one location to another. Water molecules, they possess kinetic energy. That means water molecules, they have kinetic energy, and that they are able to move randomly. They are able to move randomly from one place to another, either in liquid or in gaseous form. When we are saying in liquid form, that means it is normal water, but in gaseous form, that means we are talking of water vapor. So water molecules, either in normal form or as a water vapor, they possess kinetic energy, and thus they move. In liquid form, they will possess lower kinetic energy, but in gaseous form, they have a higher kinetic energy. Now we are saying that the greater the concentration of water molecules, then in that system, and the higher it is water potential. The greater the concentration of water molecule in that system, the higher it is water potential. It is water potential. So pure water has the maximum or highest water potential, which by definition it is 0. Pure water has the highest water potential, which by definition it is 0. Now, what do we mean? You'll understand it later, why the highest water potential it is 0. If two systems containing water are in contact, such as soil and atmosphere, or cell and solution, soil containing water and atmosphere containing water, but what it differs is that the concentration or the amount of water in the soil and atmosphere, it is different. Or even when you take the cell and then you put it in the solution containing water. Again, when we are talking of solution, we mean that we have taken a solute and then we have dissolved it in solvent, and in most of time this solvent, it is water. So all of these conditions, we are involving the putting together in contact the two medium containing water. Then the random movement of water molecule will result in the net movement of water molecule from the system with higher water potential or higher energy to the system with lower water potential or lower energy. So there will be net movement of water from the system where we have a lower water potential or low energy to the system where we have a higher water potential or high energy, depending on the systems which are in contact. Kwa inategemea kama umeweka cell na solution, which one has the higher water potential or which one has the higher energy to move water from one side to another. The one with the higher energy to move water is the one which will result in the movement of molecules from that side to another side, from that side to another side, until the concentration of water molecule in both the two systems is equal. This is a diffusion involving water molecules and is specifically called as osmosis. So there will be movement of water molecules from the side of a higher concentration of water molecule to the side of lower concentration of water molecules. It is because of the excess kinetic energy or excess amount of energy possessed by water molecules in the side of high concentration. This specific category of diffusion is known as osmosis. Now, water potential is usually expressed in pressure units by biologists. It is usually expressed in pressure units by biologists. So, even if it represents the extent to which water will move from one side of the solution to another, but its expression is in the pressure units. So what we are saying that pure water had the highest water potential, and by convection this is 0. Note that pure water had the maximum water potential, which is 0. That is the first thing you need to know. And water always moves from region of higher water potential to one with a lower water potential. Then we are saying that all solutions have lower water potential than pure water, and therefore they have negative values of water potential at atmospheric pressure and defined temperature. They have negative values of water potential. That is the very important thing for you to remember. Kama ambavyo nimekuambia kwamba pure water na water potential is 0. So addition of solidity decreases the water potential, decreases the ability of water molecule to move from that solution to another solution. So addition of solidity decreases water potential to a negative value. Is how we shall discuss later about the factors affecting the water potential. And then we are saying osmosis can be defined as the movement of water molecule from region of a higher water potential to region of low water potential through partially permeable membrane. So now we have the modified definition of osmosis, because now we know about the meaning of water potential. Previously, we discussed osmosis as the movement of water molecules from the region of the high concentration to the region of the low concentration. But now we don't define again osmosis based on the concentration, but we are basing on the water potential, because we know that the higher the concentration of water, the higher the water potential. The lower the concentration of water, the lower the water potential. So in other words, it is very easy to say that it is the movement of water molecules from the region of the higher concentration, the higher water potential, to the region of the lower water potential through a partially permeable membrane. Now let's discuss about the few advantages of using water potential. Why is it advantageous to use water potential as the quantity of measurement or in a calculation of different things regarding transportation in a plant? Water potential can be regarded as the tendency of water molecule to move from one place to another. Tendency of water molecule to move from one place to another. The higher or less negative the water potential, the greater the tendency to leave the system. The greater the tendency to leave the system. That means if we are putting in contact two solutions having different values of water potential, water will move from the side with the higher water potential to the side with the lower water potential. That's how water will tend to move. And as we said that water potential is mainly affected by addition of impurities, which normally are called the salts of a solution. If two systems are in contact, water will move from the system with a higher water potential to the one with the lower water potential. Water will move from the system with the higher water potential to the one with the lower water potential. The two systems do not necessarily have to be separated by a membrane. The two systems do not necessarily have to be separated by a membrane. So water can be said to move through a plant down a gradient of water potential. That is the major and important concept you need to understand about water potential. That it can be said to move down a gradient of water potential. If our water potential is higher in one side and water potential is lower in another side, that means water will move from the side of a higher water potential to the side of a lower water potential. The steeper is the gradient, the faster the flow of water along it. The steeper is the gradient, or the steeper is the difference between or the higher the difference between the water potential in two sides, we determine the speed by which our water will tend to move from one side of the solution to the other side of the solution. Now, this is just the discussion about the introduction in the plant-water relation, and we have discussed about the concept of water potential, how it affects osmosis and its advantages. And as we said that the highest water potential is zero by convection, and that is the water potential of pure water. But we have water potential of solution which are negative in value. In the next session, we will be discussing about the factors affecting water potential, and then you can move to different calculations regarding water potential. This marks the end of our session. If you need these notes, you can visit the Kipaji app and you can buy them for very low cost. For any concern that you have not understood the session, you may contact me by using the contacts in the description below. Don't forget to join our Telegram group for discussion with your fellow students and to meet different teachers from different areas which can help you to answer your questions and to tackle your questions in the exams so that you can perform well in your NECTA exams. Dr. Mlelwa Lecturers for better performance of NECTA exams. Let I wish you nice studies.